So good evening, Tuesday night, January 29th, 8 to 9 p.m., Math 123. Welcome everybody, welcome back. Hope you had a great week. And we are looking at section 4 and 5 today. So sections 4 and 5. And I want to let you know what the assignments are. The assignments are the web work from sections 4 and section 5, and then the Excel pie charts assignment. The discussion board is really for next week, but you can take a look at it if you need to already. But anyway, we're doing web work 4 and 5 in the Excel pie charts, and that's what we have for this week. And again, remember that web work 3 and quiz 1 are due tomorrow. Okay. All right, and then keep sending me those questions by email. Sometimes it takes me a minute to get back to you, but I'm finding that sometimes if I wait a few minutes and check, you've already gotten your answer and it's correct. So that's a good thing. All right, so we're looking here at page 35 to start. And section 4 says applications of per capita and proportions. So we looked at a little bit about per capita last week, and we're going to move on to some applications with per capita and get some further meaning. So it says here we can also use proportions to consider what-if scenarios. Consider the table to the right, which contains the total amount of money spent on K-12 education for the 2014-15 school year. According to the table, Illinois spent $28.54 billion from a population of 12.9 million. So notice billions and millions. With a population of 6.6 million in Indiana, what would be the expected value of K-12 education expenditures if the two states were proportional? So when we say two states are proportional or two things are proportional, that means that the fractions would be equivalent. So right now we have all the data for the expenditures and the population. And the question is, what would Indiana's expected expenditures be if that fraction was the same as the Illinois fraction? So let's get this set up. We're going to take the Illinois expenditures, 28.54 billion, and the population, 12.9 million, and then Indiana's population, because we're trying to find the expenditures, what would they be? We're making a prediction. So Indiana's population, 6.6 million. I want you to notice something here. When we solve this proportion, we're going to multiply diagonally again and then divide by this number right here. So look at the units. We have millions times billions, and then we're going to divide by millions. So the millions cancel out, and our answer will have billions. And so we don't actually have to put the powers of 10 on here, as long as we recognize what our answer is going to have to be in. Our answer is going to have to be in billions. So we would do 28.54 times 6.6, and then divide by 12.9. And this is dollars, and people are on the bottom. Okay, so that's how we would set that up. It looks like some of you put the answer in the chat box. Awesome. 14.6 billion. I didn't do this problem, I just set it up. So, oh yeah, the answer is right here. So it says this means that we could expect Indiana to spend $14.6 billion on K-12 education if Indiana chose to adopt Illinois spending patterns. And it says compare this to the actual expenditures of $9.97 billion. How do those compare? Well, it looks like it's about, I don't know, almost $5 billion more, right? So let's look on page 36. And actually, if you look in your book, I don't have this on the screen. But if you look in your book, there's a problem, number 1. It says if the amount of K-12 education expenses in Illinois were proportional to those in Indiana. Oh, excuse me. Let's see. Yeah, okay. So if the amount of K-12 expenditures in Illinois were proportional to those in Indiana, what would have been the expected expenditures in Illinois? So this question is number 1, and it's not up on the screen, but it is on page 35 in your book. And this one we would set up as, we would do Indiana, and Indiana looks like 9.97 billion, 6.6 million. And then Illinois, if we're making the projection for Illinois, notice that Illinois, we have the population and we don't know the expenditures. We would be trying to figure those out. And it is right about 19.5 billion. Let's see, my attendance good? All right, so let me check out the chat box here. All right, everything looks good, 19.5 billion, and this would be dollars. And then if we were going to write a sentence, it would say something like, if Illinois spent proportional dollars to Indiana for their K-12 expenditures, they would spend $19.5 billion. And this is almost, well, it looks like it's about $9 billion less than they currently spend. So something like that for a meaningful sentence. We're going to flip over to page 36 here. And it says, we're going to look at the gross domestic product. It says the gross domestic product, GDP, is the market value of an officially recognized final goods and services produced within a country in a year. So it's like this basket of goods and services that we compare every year. How much does it cost? How much did it cost this month versus how much did it cost next month? And then the following month, and we can look at them year to year also. And so it says the GDP per capita is the market value of all officially recognized goods and services produced within a country per person. Remember that per capita means per person. The GDP per capita is often considered an indicator of a country's standard of living. So here's this table, and we're going to calculate the GDPs per capita. And again, you want to make sure you look at the units that we're doing here. We have billions divided by millions. And so that first one, why don't you go ahead and do that? Take 1,532 billion divided by 22 million. And then since it's dollars, go ahead and take it out to the nearest penny. So remember, you have to watch your units here. All right, so I like Megan's answer. So you have to take, so what I did in my calculator, since I didn't do it in the scientific notation, I just know that billions have 3 more zeros than millions. So I did 1532000 divided by 22. And that gave me $69,636.36. So if you didn't get that, try Canada's, okay? Go ahead and try Canada's. And then after we get Canada, I'll fill in the rest. And it looks like you're getting it just fine. So it is $51,002 All right, let me see what the next ones look like just so we can answer the questions. So the next one is for China, it's $6,094.07. For Madagascar, it is $455.11. And let's see, the United States, $51,732.48. Okay, so I put those there so we could answer the questions. And I mean, let's just notice some things here. Australia has the highest GDP per capita. Madagascar has the lowest. China, why do you think China's is only 6,000 compared to the US being at 52,000? Yeah, there's so many people. There are, I mean, it looks like comparing China to the US, there's about 4 times as many people. So let's see, which country has the highest GDP? Looks like Australia. And the lowest, oh, I'm sorry, I'm not even reading this right. The highest GDP, that's this number here. So it looks like the US. And the lowest GDP, let's see, the lowest GDP looks like Madagascar. And then which country has the highest GDP per capita? That would be Australia. And the lowest GDP per capita is still Madagascar. So it says China's GDP is more than 4 times the size of Canada's GDP. Why is China's GDP per capita so much less than Canada's? And again, we said it's because of the population, that huge population that China has. That's a capital C. So I'm just going to say the population of China is so large in comparison. And then number 4 says if China's GDP were proportional to Australia's, what would China's expected GDP be? And then how does it compare? So let's see. So if China's were proportional to Australia, so I'm going to put Australia's numbers first just so I can keep them organized. So let's see, Australia's GDP looks like 1532 times 10 to the, let's see, it's billion, so that'd be the 9th power, divided by the population, 22.0 times 10 to the 6th. And then we'll look at China. We don't know what China's expenditures or what their GDP would be, but we know their population. And their population is 1350 times 10 to the 6th. So we're going to multiply diagonally and then divide by the 22. So we can do 1532 times 1350 divided by 22, and we'll get our answer would actually be times 10 to the 9th, whatever it is. And we can just list that as 94 trillion, just like I see you doing in the chat box. Perfect. All right, so trillion is 3 more decimal places than billion, so that's why we said move that 3 places and make it 94 trillion. All right, you guys are doing great. So any questions so far on either the expectations from the per capita or from the GDP per capita? Okay, well, let's move along then. Let's look at page 39. So page 39 talks here about the federal budget. And at the top of the page, it says, according to Government Publishing Office, the GPO, in 2017, the U.S. government had an income of $3.32 trillion and expenses of $3.98 trillion. And what I want to know is, what is the difference? And is it a surplus or a deficit? What is the difference? Well, let's see. We're going to take 3.98, take the larger one minus the smaller one, 3.32. And these are trillions, right? So we get 0.66. So 0.66 trillion, remember that's the same as 0.66 times 10 to the 12th. We could write this also as 660 billion, if that makes more sense. So remember, if we move the decimal 3 places to the right, that's going to go from trillions to billions. And it is a deficit. How do we know it's a deficit? Yep, the expenses are more than the income. That's right, that makes a deficit. We don't want to have that happen in our personal bank account, that's for sure. All right, so number 2 says, if the average citizen with a per capita income of $46,550 operated like the US federal government, what would the expenses be? And so we're going to set up a proportion. And we can do, I guess we're looking at expenses. I'll put expenses on the top and income on the bottom. So US and citizen. So here's how this would look. 3.98 times 10 to the 12, or trillion, or excuse me, 3.32 on the bottom, times 10 to the 12, or trillion, and then the person's income, that goes on the bottom, 46,550, and we're trying to find out what their expenses would be. And so we can just multiply diagonally. We don't have to worry about the times 10 to the 12s because they actually cancel each other out. And divide by 3.32. And let's put this in dollars and cents. It looks like some of you already are. Perfect. So the expected expenses would be $55,803.92. I think that's what everybody got. So here's what we're saying. If we make $46,550 a year and we spend $55,803, that's the same as what the government is doing with its trillions of dollars. Okay, and number 3. I'm actually going to give you a couple minutes to do number 3. And what I'd like to do is have you not put your answer in the chat box, but give me a hand raise when you have number 3 completed. All right, give me a hand raise when you have both of these completed. All right, well, I see a few hands raised here, and I tried to get you started. If you weren't started yet, we're taking the deficit and we're doing per capita, so per person. Deficit was 660 billion, and the people are 326 million. So taking that and dividing, I got $2,024, or excuse me, yeah, 2,024 and 54 cents. So that's what I got when I found the deficit per capita. And the next question says compare this with the per capita income. So if we're going to compare it to the income, we can take the deficit to the income. So 2024.54 divided by the income, which was it was at 46,550. And if we divide those, we get 0.043. Now, since this part right here, well, let me tell you what this 2024.54 actually means also. That 2024.54, what that means is that each person, since it's the deficit per capita, that would be what each person would be responsible for in order to pay off that debt, in order to make up that gap between the expenses and the receipts. So each person would be responsible for $2,024.54, every single person. So now, since that 2024 would be like, that would be, we'd pay the government that to get everybody, to get the whole deficit gone out of our income of 46,550. And since it's a part to whole, we can actually write it as a percent. So we could say something like 4.3% of the average person's salary would be needed to bring the deficit down to zero, or to eliminate the deficit. So we could say something like that as a meaningful sentence. $2,024.54 from each person is what it would take to eliminate the 2017 deficit, or 4.3% of the average person's income is what it would take to eliminate the deficit from 2017. So something like that for our meaningful sentences. The last application we have in this section is called it's about the consumer price index and inflation. So we'll take a look at this. We'll take a minute to recap, and then we'll answer any questions and move on to section 5, okay? So the consumer price index, it says inflation is the rise in the general level of prices of goods and services in an economy over time. The consumer price index is a monthly number that reflects changes in the prices paid by urban consumers for a representative basket of goods and services. So this CPI represents the changes So the CPI is compiled by the Bureau of Labor Statistics and calculated from an average CPI from 1982 to 1984 of 100. CPI is a weighted average, which we'll look at later, but it's a price of more than 60,000 goods, services, and housing costs. To the right is a table of the annual CPI value since 1977. So it goes 1977 all the way up to 2017. The annual value of $172.200 for the year 2000 means that the collection of goods and services that would have been $100 in 1983 would cost $172 in 2000. And then in 2017, it would be $245.12. So it says, what is the trend? Well, we can look at that and see that the trend is that this CPI is going up, right? and that means that the cost of goods and services is increasing. So what we're going to do is do some calculations using CPI. And so in number one, it says, in 1979, a McDonald's hamburger cost 38 cents. What does that equate to in 2015 dollars? And then it says use either of the strategies. So the strategies, it's really just the same strategy. It's setting up a proportion. And the first proportion on the left is dollars over dollars, CPI over CPI, with the corresponding years next to each other. And then the right-hand proportion is the dollars over the year's CPI for each year. And that's the way I'll set mine up. So for the 1979 McDonald's hamburger, it says it cost 38 cents. And so what we would do is we would put 38 cents over the CPI for 1979. So to look that up, it looks like it's 72.6. And then we're going to put, we don't know how much it is in 2015, but we know the CPI in 2015, and that is 237.017. And then we're going to solve the proportion as we normally do, multiplying diagonally and dividing by the extra number. And I see some of your answers in the chat box. Let's see. I'm going to punch it in my calculator. See what I come up with. See who it matches. So let's see, I'm going to do 0.38 times 237.017 and then divide that by 72.6. And I got $1.24. So it says, how does this compare to the actual current price of a McDonald's hamburger? So the price we just found would be the price calculated with inflation. The actual price is probably, what, $1 off the dollar menu? So probably a little bit more than the actual price. So that's a good thing because, you know, if the inflationary price is higher than the actual price, then that's good for the consumer because we're paying less than we would have if the price kept up with inflation. So it's pretty comparable. Number two says, according to the National Center for Education Statistics, the starting annual salary for a college graduate in 1983 was $25,000. What would be a comparable starting salary in 2013 if it kept up with inflation? So again, we're going to set up a proportion. And let's say $25,000. So this is the 1983 going down. $25,000. In 1983, the CPI was 99.6. And we're trying to find the dollars in 2013 dollars. So we need 2013's CPI, which is up here. So it's 232,957. So this is 2013. So we don't want to put the year in there, we want to put the CPI in there. And then multiplying 25,000 times the 232,957 and dividing by 99.6, we come up with $58,473 and 14 cents, just like I see in the chat box. So good job. I see that many of you had it in there before I calculated it, so good job. Megan, Kayla, Shay, right, and Kendra, Kelly, Pamela. Good job. And Kaylee and Estefani, excellent. Okay, good. So let's see, number 3 is on the next page. And I am going to have you guys take another minute. And then if we do group work today, it's going to be in the next section. So take a minute, give me a hand raise when you have these two completed. All right, I'll give you a couple minutes to do that. And again, don't put your answer in the chat box. Just hang on a minute, okay? Just give me a hand raise when you're done. All right, so the top half of my attendance list all has their hand raised. I don't know about the bottom half of my attendance list. I don't know why, if you guys aren't finding the button or if you're not done yet, try and locate the hand raise button if you haven't already and you're complete. Okay, so I've got just a few of you not done yet, so we'll go ahead. So number 3 here says, suppose a 20-ounce soda cost 25 cents in 1977. So we need the 25 cents and we need the 1977 CPI, which is 60.6. We're trying to predict the cost in 2015. So we need 2015 CPI 237.017. And when we multiply diagonally and divide by 60.6, we get that the cost, the predicted cost, if it were comparable, if it were staying up with inflation, would be 98 cents, right? And so it says, how does this compare to the actual cost of a 20-ounce soda in 2015? Well, if you go out to the gas station and get a 20-ounce soda, it's going to cost you probably $1.50 or $2. So what we could say is we could say the price of a soda is higher. Soda prices have increased faster than inflation. So that answers the second question. So soda prices are higher. Than the inflation price or the inflation amount. And we could say that the soda prices, also another way to say this, soda prices have increased faster than inflation. So like that hamburger earlier, the hamburger price, the inflation price was $1.24, and so the actual cost is a little bit less. Here with the soda, the cost of the soda is actually higher. So just note those differences. Okay. All right. So that does it for section 4. And I wanted to stop for a second and see what questions you have on section 4. If you have any at this point. Is there something that you saw in one of the videos that you're confused about, or anything you missed? Something not making sense? This is the time. I want to make sure you understand, okay? All right, let me find page 43. Question C. Okay, so on page 43, question C says, use the CPI table to determine whether minimum wage has kept up with inflation since 1979. And let's see. So there's a little chart there. It says minimum wage in the state of Indiana by selected year in dollars. So in 1979, the minimum wage was $2. So I need 1979 CPI, which I think was at, let's see, 92 points or 72.6. And then we're going to look at compared to today, 2017. So we want the CPI for 2017, 245, 120. So we know the actual, and we're trying to find out what it would be if it were keeping up with inflation. And so we're going to take 2 times 245, 120, and then divide that by 72.6. Wait, I don't know if I like this or not. $2, 2, 3. Yeah, so in 1979 it was $2, and let me just make sure my CPI is correct. 72.6, and then in 2017, 245, 120, and we're trying to find the dollars. So yeah, let me put this in my calculator. 2 times 245.120 divided by 72.6. So I got $6.75. So that means that if wages were increasing at the inflation rate, minimum wage would be $6.75. But the actual minimum wage is $7.25. So this is the actual. This is the inflation, what it would be if we were keeping up with inflation. And so this shows us that the actual minimum wage is outpacing inflation. And that's good because, if it's outpacing the increase in the cost of goods and services, that's a good thing. So that's page 43, letter C. All right, any other questions? I think that's the only one I saw. And we compared the expected CPI with the actual. Let's see. Oh yeah. Well, we're really trying to look at it's the same idea, but we're not comparing the CPIs. We really want to know what the inflation dollar amount is for the minimum wage, because the next question would be, if there were a next question, would be, did the wage keep up, and make a statement about it. We can say that the minimum wage is actually 50 cents higher than it would have been if it were keeping up with inflation. So even though it's the same idea, you want to make sure you're doing it correctly with trying to investigate what the new dollars would be, the new price or the new wage, because that's what we want to be able to use to compare. Alrighty. Well, Kelly, the minimum wage wouldn't be 263,175, right? That doesn't make sense. That would be what the CPI would have to be if 725 was the inflationary dollar amount. So it's not quite the same. All right. So we're going to look at section 5 and we're going to do this mightily fast. Okay. So section 5 says working with percentages, and it says using proportions to solve percent problems. And I want you to see this part right here is so the way I set these up, and I've taught this for, I don't know, a quarter of a century. And there's really two ways we look at this. One is if the words are using is and of, we will put the is over the of in the percent over 100. Or we could look at this as part to whole percent over 100. So the whole amount being the 100% and the part being whatever percent you get. So let's just straight look at this number 1, 2, and 3. And number 1, it says 36 is 40% of what number? So 36 is, so we would just put that in the is spot. It says of what? We don't know what the of part is. And then we have the 40%. So 40 and the 100 is always the same. So we're going to do 36 times 100 divided by 40. And we get 90. And then we want to just check and make sure this makes sense. 36 over 90, does that equal 40 over 100? So that's the question. If you reduce these two fractions, 40 over 100 is 4/10. And if you reduce 36 and 90, divide them both by 9, you get 4/10. So, yeah, that's correct. And then number 2, 527 is what percentage of 850? So we're going to do 527 of 850. And it says what percentage? So we don't know the percent. So we're going to do 527 times 100 divided by 850. And we get 62%. So it's just straight 527 times 100 divided by 850. And we know that we're getting the percent. So put a percent sign on the end. In web work, you might not have to put the percent sign in. I'm not sure. I don't remember. So number 3, then it says 15% of Americans are left-handed, and there are 314 million Americans. How many Americans are left-handed? So we have 15%. Let me move this over a tiny bit. So we have 15% out of 100. And we have to just decide if this 314 million is the part or the whole. And it is the whole. Thank you, Kendra. So we're trying to find out how many millions are left-handed if they're equivalent to 15%. So we're going to do 15 times 314 million divided by 100. And it looks like you all are getting 47.1. Is it 47.1? No, it is 47.1 million. So it says round to the nearest whole person. Well, let me throw this in my calculator again. So 15 times 314 million divided by 100. So yeah. So 47,100,000. Southpaws. All right. So again, remember, it says round to the nearest whole person. So if you put 47.1 in your answer blank, you're going to get it incorrect because it's 47.1 million. So it would be 47,100,000. I don't think you want to put the commas in on web work. I think that if you leave those off, you'll get it correct. If you put a comma in, sometimes it reads it as an array of numbers instead of just a single number. So 47,100,000 lefties or southpaws. All right. Yeah, I've got 7 more questions left. Let's see if we can get through them. So flipping over to page 47, these are set up a little bit different because the percentage now is more than 100. And so if we look at these, we're still going to set it up the same way though. 75 is of what number? We don't know. And even though the percent is more than 100, we're still going to put it in the percent spot and keep 100 in the bottom. So 75 represents something that's more than 100%. So we're going to do 7,500 divided by 125, and we do get 60. Ticket prices, same idea. If they used to be $30, well, it says assume the ticket prices are 125 of what they used to be. They used to be 30. How much are they now? So the 30 in this case represents the old price, the 100% price. We're trying to find the price now at 125%. So you should see if they used to be 30 and they're 125% of what they used to be, how much are they now? You should know that your answer has to be bigger than $30 because 125% is more than 100%. So if they were 30 and the price is higher because it's 125% now, our answer needs to be higher. So we're going to do 125 times 30 and then divide that by 100, and we do get $37.50. All right, last one I'm going to do with you. It says the doctor says you need to consume fewer calories. You should be consuming only 2,000 calories, but you are eating 2,600 calories. We want to know what percent that is. So you should be consuming 2,000. That's the 100%. You are consuming 2,600. We want to know what percent that is. So 2,600 times 100 and then divided by 2,000. Is 130%, just like you're putting in the chat box. Okay, so let's see here. I've only got about 5 minutes left. It's not enough time to put you in groups. So let's see how I want to do this. I guess what I'll do is I'll set them up, and if you have a question about why they're set up the way they are, then ask. And then as I set them up, you guys can calculate the answers. All right, so there's how we set each of these up. And again, in number 1, the $3.70 is the part to whole, $74. The tax rate, is going to be less than 100%. It's actually 5%. And in number 2, it says that 24.7 of the 6 million have German ancestry. So this is the German ancestry, this is the German ancestry, this is the whole, this is the whole. And it looks like it is 1,594,200 people have German ancestry. And number 3, the part to whole again, the tax to the gross amount, 396 to 1,800. So 396 times 100 divided by 1,800 is 22%. And then the last one here, 575 is taken out, 23 is taken out. So 575 is the same as the 23%. We need to find the whole amount. What was the original pay? 575 times 100 divided by 23. And again, you want to look at these words and tell, okay, if 575 is taken out, that means that however much she made has to be bigger than that. And if you did something like 575 times 23 and divided it by 100, you'd find out that that answer is lower. And so that would give you a signal to say, oh, I did something wrong. All right, so we don't really have time to go over the Excel on because you do an Excel pie charts. However, the instructions on page 51, so 51 to 52, those all are how to make a pie chart. And I think there's support videos about Excel also in your Canvas course. Check out that video on how to make a pie chart. So I'm going to end the recording here and then stick around to answer some questions.